find the condition of perpendicularity of two given straight lines. If the straight lines AB and CD be perpendicular to each other, then theta is equal to angle between the lines is equal to 90 degree. Here theta is equal to 90 degree. If theta equal to 90 degree, then AB is perpendicular to CD. Okay. So from figure 9, from this figure, this is alpha, beta and theta. Then alpha is equal to theta plus 90 degree. Theta plus this is 90 degree. Theta plus 90 degree. Alpha is equal to theta plus beta, theta equal to 90 degree. Therefore, alpha is equal to 90 degree plus beta. 90 degree plus beta. 90 degree plus beta. Therefore, tan alpha is equal to tan 90 degree plus beta. Tan 90 plus beta is equal to minus cot beta is equal to minus 1 upon tan beta. The tan alpha is equal to minus minus 1 upon tan beta. That implies this is M1 and this is M2. So M1 is equal to minus 1 upon M2. That implies M1, M2 is equal to minus 1. The condition of perpendicularity of the lines y is equal to M1x plus C1 and y is equal to M2x plus C2 is M1, M3 is equal to minus 1. Conversely, if this M1, M2 is equal to minus 1, then tan alpha into tan beta is equal to minus 1, or sin alpha by cos alpha, sin alpha into sin beta is equal to minus of cos alpha cos beta. That implies cos alpha cos beta plus sin alpha sin beta is equal to 0, or cos of alpha minus beta is equal to 0. That is alpha minus beta is equal to 90 degree, theta is equal to alpha minus beta is equal to 90 degree. Okay. Therefore, the straight lines AB and CD are perpendicular to each other. Next, we have to find the equation of straight line perpendicular to a given straight lines. Let x plus by plus c is equal to 0 be the equation of the given straight line. Then from 1 we get by is equal to minus x minus c, or y is equal to minus a by b x minus c by b, where b not equal to 0. And equation from 2 it is evident the slope of the given straight line is minus a by b. Let m be the slope of a line which is perpendicular to the line 1, which is perpendicular to the line 1. Then we must write m into minus a by b is equal to minus 1, because m1 m2, since m1 m2 is equal to minus 1. Okay, m is equal to b by a. Therefore, the equation of a line perpendicular to the line 1 is y is equal to mx plus q1. That is, y is equal to b by a x plus q1, or ay is equal to bx plus a q1. or bx minus ay plus k is equal to 0, where k is equal to a k1 is an arbitrary constant. Next, identical straight line. Two straight lines are identical if their coefficients are proportional. Thus, the straight line a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0 are identical if a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Proof. a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. This is 1, this is 2. Slope intercept form of straight line 1 is y is equal to minus a1 by b1x minus c1 by b1, and straight line 2 is y is equal to minus a2 by b2x minus c2 by b2. If 1 and 2 represent the equation of the same straight line, then their slope are equal. That is minus a1 by b1 is equal to minus a2 by b2. That implies a1 by a2 is equal to b1 by b2. Again, the y-intercept of the line 1 and 2 are also equal. Therefore, minus c1 by b1 is equal to minus c2 by b2. That implies b1 by b2 is equal to c1 by c2. Therefore, 3 and 4, it is clear that 1 and 2 will represent the same straight line when a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Okay.